Exam 3, there are 3 main categories from which all the questions are going to be taken: stoichiometry, composition, and molarity. By coincidence, each of those happens to have 3 subsections, which I've labeled A, B, and C here. So, in summary, there are 3 general categories and 9 basic types of questions that will make up the bulk of the exam. First of all, let's talk about stoichiometry, which was found in chapters 8 and 9 of the reference textbook. What you're going to have there are questions that, and most of this test is going to be calculations. So you're going to need the calculator. Make sure you're good with that online calculator. Right, so the stoichiometry, the main part of it's going to be asking you to go from like grams of something to how many moles of something. Or I've got this many particles of something, how many grams do I have? Or I have so many grams of A, how many grams of B do I have? Or I have this many particles of B, how many moles of A do I have? They are all essentially the same type of problem, stoichiometry problem. It's where you're given something, a star, and you box, and you're asked to calculate something else. So look back at the videos where it talks about the box equals star approach, and you will get most of those correct if you know how to do it. There are 2 variations on stoichiometry, or at least require the stoichiometry data, and one is percent yield. And that's where you do what? You take the actual amount produced, and you divide that by the theoretical amount. What's your theoretical? It's amount that you get by doing the stoichiometry calculations. And that is your percent yield. Limiting reagent is where you have 2 reactants, A plus B, and let's say it's going to C, and you have to determine which one of those is in least supply that's going to produce the least amount of product. That's important because you don't always have exactly the exact amount of product of A and exactly the amount of B. Usually, there's going to be an excess of one of those 2 that you use. And so you need to determine which one's limiting because you need to know how much product you can make. Okay. Enough on that. So those are the 3 basic types. Composition. That's where I watch the videos. We've got a molecular formula, and you're going to go to weight percent. So the first thing that you want to do is to know how to work that type, which I call category A. That's one type. The second type that you're going to want to know how to do is to go from, that's empirical formula, and this is weight percent composition, and this very first one was the molecular formula. Okay, first type of question is go from molecular formula to weight percent. The second type is to go from weight percent to what's called empirical formula, and that's what I call the type B. And then finally, the third one is where you go from empirical formula and you calculate molecular formula from that. Okay, and from that, you're going to need the molecular weight of your molecule. Normally, if the molecular weight is given and you're given an empirical formula, it's going to ask you for the molecular formula. And finally, there was one variation on that, which was going to be a little bit harder. And that's if you start all the way up here, it is possible to go all the way to molecular formula. So on the exam, if I were you, I'd be looking for one type A, one type B, one type C, and then one of these more complicated. I would look for at least 4% composition problems. Molarity, I would be looking for a minimum of 3 types of molarity problems, a minimum, mind you. Okay, and so those were one where you calculate molarity. Those are easy. You can just do easy dimensional analysis. All you need to know for that is what to do molarity. You do how many moles of solute per liter of solution. Just use dimensional analysis and then fill in your variables on the right side until you come up with moles per liter, because moles per liter is the molarity. Okay? That's the key to working these. Sometimes you use molarity as an M, but sometimes you have to break it down into the units, moles, and liters. Okay, that was type A. The second type B is where you use molarity to calculate something else. So, and typically what you're going to do is it's going to give you the molarity, and it's going to give you the milliliters of solution, and you're going to calculate the grams of solute. Okay, and then the third time was the easiest kind. That's one where you don't even really need to know this. It's more of a plug and chug type where you just use MV equal MV. The molarity times the volume before you concentrate or dilute the sample is equal to molarity times volume after you do the concentration or dilution. Those two have to be equal. So what this means is, right, if you've got the molarity and you weigh, if you got a sample at a certain concentration, molarity, and volume, if you increase the volume, what did you do? You diluted it. So what? The molarity is going to be less. These have to be in balance. The only tripwire there is to remember, this volume is total volume. It's not the volume that you added to the original sample. It's the total volume you ended up with. So with that, that's your 9 main types or 9 main types of problems that you're going to have. Of course, you're probably going to have a 10th type and the 11th type, and the 10th type is what? A sig fig. I promised you that I would try to put a sig fig on every exam, and I did remember to do it on this one. And of course, the other one I told you is fair game for every test is a nomenclature problem. So look for a bunch of those types, most of them calculations, and you can be guaranteed you're going to have at least one sig fig and at least one nomenclature. And that is what's going to comprise the bulk of exam 3, which I think is going to be about 24 questions long.